This is the prerequisite review for Section 3.5, Introduction to Rational Functions. This worksheet will cover two objectives. We will begin with Objective 1, Restricted Values of a Rational Expression. Keep in mind our denominator cannot be equal to 0, okay? So let's go ahead and look. Here in number 1, we will go ahead and set k plus 2 equal to 0. And we see that k equal to negative 2 makes the denominator 0. So k equal to negative 2 is our restricted value. Looking at number 2, we have two factors to set equal to 0. We have x equal to 5 halves and x equal to negative 8. And both of those are our restricted values. Looking at number 3, we need factors in the denominator. So here, if we take a look at the denominator, we have, we have two numbers that add up to 5 and multiply together to equal a 6. You guessed it, a 3 and a 2. So we would divide both of those by m, and we have m plus 2 and m plus 3. We're back to where we were before. We do not want the denominator to equal 0, so we set each one of those factors equal to 0, and those are our restricted values. Again, we set the denominator equal to 0, and x equal to 0 is our only restricted value. I wrote restricted value so that you keep in mind that we are not solving these. We are merely stating the values that x cannot be equal to. Okay, now we're moving on to Objective 2. And in this objective, we're going to be simplifying rational expressions. And sometimes we will factor first. And we'll get there. Looking at number 5, as you can see, p plus 5 divided by p plus 5 is 1. So now we can say that this expression is equal to p minus 3 divided by p plus 4. Okay, looking at number 6, we see that we will have to factor first. So in that denominator, the common factor between 20a and 25 is a 5. And factoring out a 5 from the denominator, we have 4a minus 5. Here you can see 5 divided by 5 is equal to 1. So we have 1 divided by 4a minus 5. Okay, moving on to number 7. You might think that we can't simplify that, but I want to make a note. I want you to know that the opposite of a minus b is equal to b minus a. So we can switch the places of the actual subtraction values. So we can make that an x minus 5, but we would have to put a negative in front of that. So this is actually equal to x minus 5 divided by minus the opposite of x minus 5. Okay, so we could say since 5 minus x is equal to the opposite of x minus 5. So now we were able to cancel our x minus 5's, and we are just left with a negative 1. Looking at number 8, we will factor the numerator. So factoring a 4 out of the numerator, we end up with q minus 1. And factoring a 12 out of the denominator, we have a 1 minus q. Now, keep in mind that we can divide a 4 divided by a 12, and that leaves a 3 in the denominator. So we have a q minus 1 divided by 3 times 1 minus q. Now keep in mind that 1 minus q is the same as the opposite of q minus 1. And let me just write this. Okay, so now we can cancel the q minus 1's, and we have a 1 over a negative 3. Okay, continuing with our simplifying our rational expressions, we see that we can factor both a 6 and a p out of the numerator, and we're left with a p plus 2. And in the denominator, we can factor out just a 2p, and here we have a q minus 2. So our p's cancel, and 6 divided by 2 is a 3 over 1. So we have a 3 times p plus 2 divided by q minus 2. Looking at number 10, again, in the numerator we can factor out a 2. In the denominator, we are going to have to factor. So we will come over here, and we need two numbers that multiply together to get a negative 10 and add up to a negative 3. And so if you're thinking a 5 and a 2, and then 5 minus 2 is equal to 3. So it's a 5 and a negative 2. And so we end up with x plus 5 and x minus 2. And actually, this should be, we want them to equal a negative 3, so that's going to be a negative 5. So that sign was a negative 5 and a positive 2. We could tell when we multiplied those that that was not correct. Let me just fix that a little bit. And now you can see that our x plus 2's cancel, and we end up with a 2 divided by x minus 5. So taking our time, also after we come up with our factoring, checking it, because as you can see, this negative was very important in front of the 5. Now, looking at number 11, keep in mind that when we have 4 terms, we are going to factor by grouping. So let's go ahead and factor that numerator. So remember, we are going to group these two terms together and these two terms together. We'll also do the same here and here. So between those first two terms, we have an A we can factor out, and we have a C minus D plus a 2B, and we have a C minus D. In the denominator, we can factor out an A, and we're left with a 2C plus D. And in the second two terms, we have a 2B, and we have, when we factor that out, we have a 2C plus D. Now, between the two terms in the denominator, we're factoring out a C minus D, and we're left with an A plus 2B. And in the denominator, we can factor out a 2C plus D, and we're left with an A plus 2B. And the A plus 2B's will cancel. Let's see if I can make this a tad bit smaller. And what we have left is a C minus D divided by 2C plus D. Okay, so 4 terms factor by grouping. Now let's go ahead and take a look at number 12. Again, we're going to factor by grouping in the numerator, and in the denominator, we have a difference of squares. So keep in mind that A squared minus B squared is A minus B multiplied by A plus B. So just some little hints there. Okay, we're going to group these two terms and then these two terms, and it looks like we can factor out an x squared, and we're left with a 5x plus 4, and then we'll factor out a negative 9, and we will have a 5x plus 4. And you can check that and make sure that that's the same. Negative 45x minus 36. So sometimes it's nice to check those. And in the denominator, we have a difference of squares, so it's x plus 3 multiplied by x minus 3, which is noted right here. So now in the numerator, we can factor out a 5x plus 4, and we're left with an x squared minus 9. And you know, that was the way it was in the denominator already. So I didn't have to factor out those. I could have just factored out the difference of squares. But here, let's go ahead and practice that difference of squares factoring. And as you can see, we are just left with a 5x plus 4. Okay, moving on to number 13, we'll combine both of these objectives, and we are going to identify the restricted values, and then we're going to simplify the rational expressions. I think it's nicer to go ahead and factor first. So if we have 3, we're left with y plus 2. And in the denominator, factoring out a 6, we're left with a y plus 2. And we do need at this point, before we reduce, we do need to go ahead and write our restricted values before we cancel. So this is important. We will set that equal to 0, and we see that our restricted value is y equal to negative 2. Okay, so you do need to find restricted values before simplifying. And looking at number 14, you can see we can only factor out a 4 out of that numerator, and we're left with a 2n minus 5. And the denominator is a difference of squares. So we have a 2n plus 5 multiplied by a 2n minus 5. And as you can see, we can simplify those. And we end up with 4 divided by 2n plus 5. Now we do have to find our restricted values. And those restricted values, we have to set both 2n plus 5 equal to 0 and 2n minus 5 equal to 0, because we have to find these before we simplify. So what we have is n equal to 5/2 and n equal to a negative 5/2. And those are our restricted values. And that concludes this worksheet.